you find probabilities when you're using simulation. So looking at the first example, a number cube is rolled 20 times. The data is recorded below. What is the theoretical probability of rolling a 6 on a number cube? So remember, the sample space for a number cube are the numbers 1, 2, 3, 4, 5, 6. Each of these numbers is equally likely. So the theoretical probability of a 6 is one of the 6 total outcomes. And if I divide that out on my calculator to see what the decimal is, and 0.16 repeating, which is 16.6 repeating percent. Looking at the data now, what is the experimental probability of rolling a 6 on a number cube? So when I look at my table, the experimental probability of getting a 6 is 1 out of the total outcomes, which they told me was 20. And if I again use my calculator to divide that out, it's 500 or 5%. Looking at our next example, a card is drawn from a standard deck of 52 playing cards. This process is repeated a total of 100 times. The results are recorded in the table below. What is the experimental probability of drawing a club? So from their data, I look at the number of times they received a club, which was 22, the total data they had, which they told me was 100 draws. That can reduce to 11/50ths. As a decimal, 2200ths. As a percent, 22%. What is the experimental probability of being a diamond or a spade? So again, looking at their data, a diamond or a spade would be 17 diamonds, 30 spades, out of a total of 100. So that's 4,700. As a decimal, 4,700. As a percent, 47%. Okay, the chance of contacting strep throat when coming in contact with an infected person is estimated as 1,500. Suppose 4 children of a family come into contact with an infected person. Use the random number table below. We're going to do 10 trials to simulate this situation. Okay, so because it's 15%, I would look at groups of 2 digits, and if the digits are, let's see, they'd have to be 14 or lower, because remember I can include the digits 0, 0. So when I look at my digits, I'm looking at groups of 4 children, so that means I have to look at groups of 4 pairs of digits. So from my first row of my table, the random digits I'm going to use are 31, 15, 16, and 47. That's one set of family. So organizing it into my table, for my first simulation, again, writing down my digits was 31, 15, 16, and 47. 15% of those to be strep throat. So I'm looking at the digits 14 and below. There are none of those, so 0 children are infected this time. Okay, looking at my second simulation, starting now after the 47. So I'm just going to switch to a different color because I'm using a different set of simulations. So 27, 88, 79, 59. So writing that into my table so I have it. 27, 88, 79, and 59. Looking through that and trying to see how many children are infected, which means the digits are 14 and lower. None of them are infected in this case. Our next simulation, continuing on, would be the digits 37, 36, 22, and 18. Recording those down. 37, 36, 22, and 18. None of those are 14 and lower, so again, none of the children are infected. Okay, our next simulation, we have 94, 74, and 48. Remember, you continue on to the next row when you're done with that top row. So writing those digits down, I have 94, 74, and 48. In this case, I do have one child that would get struck through. Okay? For my fifth simulation, I have the digits 30, 47, 74, and 10. So going down here, 30, 47, 74, and 10. And again, I have a digit or a number that is 14 or lower. So again, I have another case of where there's one child that will get struck through. Continuing on, and 78, 87, 19, 83. 78, 87, 19, and 83. No children is infected in this case. 87, 44, 64, 71. I'm just trying to remember what numbers those were. Okay, 87, 44, 64, and 71. No children are affected. 80, 72, 65, 19. 80, 72, 65, and 19. No children are infected because no numbers in that sample are 14 or lower. 45, 85, 86, 78. Down. 45, 85, 86, and 78. Again, no children are infected. And then our last random sample, we have 23, 25, 70, and 97. So putting that together was 23, 25, 70, and 97. And again, no children would get strep throat in that simulation. So now, looking at our data, use our results to estimate the probability, let's change this, of one child getting strep throat. So when I look at our simulations, of the 10 simulations, there were 2 of them where one of the children ended up getting strep throat. So based on our simulation, that probability would be 2 tenths, 1/5, 20%. Using our results, estimate the probability that at least 3 children will get strep throat. Well, looking at it, none of our trials ended up getting 3 or more children with strep throat. So that probability would be 0 out of our 10.